In this section, we're going to explore vectors in a bit more detail, and we're going to look at colinear points, finding the distance between 2 points, and unit vectors. So we're going to start off by looking at colinear points. So colinear points is a principle or a topic we should have covered before, and the key point to recognize is that with colinear points, they all lie on a straight line. So we're asked to show that the points A, B, and C with position vectors here are colinear. So the first thing we can do then is to find the resultant vector AB and AC, and then we should be able to show that they are parallel. And if they are parallel, because AB and AC would share a same point, they're on the same line. And once we've done that, we can also do the same with BC, and provided it's parallel, then that shows that all 3 points are on the same line. So in the first instance, then we need to use what we learned from the prior knowledge to find the resultant. So in order to find the resultant, then we are going to take the position vector of A and subtract it from the position vector of B. So we can interpret the position vectors here from B and A. So if we're looking at I, we're going to do -2 minus 1. For J, we're going to do 3 minus -2. And for K, we're going to do -1 minus 3. So we end up here with -3i plus 5j minus 4k. We're then going to do the same thing for vector AC. So subtract the position vector of A, which is up here, from the position vector of C, which is here. So if we do that, we end up with 3i minus 5j plus 4k. So we can see then from these two vectors here that AB is negative AC. Therefore, these two vectors will be parallel, and because they both have a common point A in common, then they must lie on the same line. So we've shown that AB and AC are on the same line. We also need then to show that BC will be on the same line. So here are AB and AC. We can also find, using the resultant formula, to find BC, which equals this. And we should be able to recognize that BC is consequently twice AC. So if it's a scalar multiple of AC, then it must be parallel. And the fact that they have, again, point C in common means that this also lies on the point. Distance between 2 points then, so building on what we've looked at earlier, we should be able to use Pythagoras here to find the distance between 2 points. So if we have a vector from A at the point 134 to B at the point 427, what is the distance between the 2 points? So just have a go at this and then we'll follow it through together. So for this question then, the first thing we need to do is recognize that in order to find the resultant AB, we're going to need to subtract the position vector of A from the position vector of B. So that will be 4 minus 1 plus 2 minus 3 plus 7 minus 4. So we'll end up with the resultant vector 3i minus j plus 3k. If we then substitute that into Pythagoras, we would end up with a distance of 4.36. Final thing we're going to look at in this vector then is drill down into unit vectors in a bit more detail. So in the first instance, if we have a vector of length 1, so suppose we have some vector A and we want to express a vector which goes in this direction, but instead of having this length, has a specific length of 1. So we call that a unit vector. So we'll use this formula, A divided by the modulus of A. So we'll have a look at an example in a moment with that. Similarly here, we could be asked to find a vector of length k in the direction of A. So this vector A will have some magnitude, and we know we can find that out using Pythagoras. But suppose we wanted a vector in the same direction, but of a different length, k. Then we would use this formula, k multiplied by a over the modulus of a. So in order to get your head around this, an example will really help. So suppose we want to find the unit vector in the same direction as the vector 3i plus 4j. So we should be able to recognize straight away that we can find the magnitude of this vector. The magnitude of this vector will be found using Pythagoras. So the magnitude of this vector is 5. We don't want a magnitude of 5. We want the same direction, but we want a vector of length 1 because we're being asked here to find the unit vector. So find a vector of length 1. So we're going to take our unit vector and then we're going to divide it by 5. And if we do that, we'll end up with a vector which is not 5, but which is in fact length 1. So the length will be a fifth of this vector, and we can multiply that out to give us 3/5 I plus 4/5 j. Similarly then, if we want to find a vector of length 10 in the same direction as this vector here, the first thing we're going to do is find the unit vector and then multiply it by 10. So in order, well, first of all, we can find the magnitude of the vector as it is. So we use Pythagoras to figure out that the magnitude at the moment is root 10. So if I divide through by root 10, this will give me the unit vector, so a unit vector of length 1. However, I have been specifically asked to find a vector with length 10, so I need to take this and multiply it by 10. So the vector, the length, will therefore be 10 over root 10 multiplied by 3 minus 1, and I can rationalize the denominator